NGAD vs China's 6th Gen fighter, a detailed comparison. Date, February 1, 2025. Event overview. The ongoing competition between the United States and China in the realm of military aviation, particularly with the development of 6th-generation fighters, has reached new heights. This report delves into the key developments of the U.S. Air Force's next-generation air dominance NGAD program and China's advancements in 6th-generation fighter technology, providing a comprehensive analysis of their capabilities, timelines, costs, and operational considerations. Key developments and timeline. NGAD program milestones. The NGAD program was initiated in the early 2010s under the U.S. Air Force's Air Superiority 2030 initiative. A significant milestone was achieved in 2020 when the NGAD prototype completed its first flight. This development was a crucial step forward, showcasing the U.S.'s commitment to maintaining air superiority. Former U.S. Air Force Chief Will Roper asserted that the U.S. had already built and flown a full-scale fighter demonstrator, emphasizing that this set a high standard for future airborne capabilities. China's progress. In contrast, China's advancements in 6th-generation fighter technology, notably with the Chengdu J-20 and Shenyang J-35, have garnered significant attention. Recent unveilings of these aircraft have sparked discussions about China's technological prowess. Nevertheless, experts suggest that while China is making strides, the U.S. has a considerable lead with the NGAD program's prototype test flights. The timeline indicates that while China is progressing, it may not yet match the advancements made by the U.S. Operational timeline. The NGAD program is anticipated to achieve initial operational capability (IOC) in the 2030s. In this timeframe, the F-22 Raptor, currently operational, is expected to be partially retired. This timeline poses strategic implications for air combat readiness in both nations. Key features of NGAD versus Chinese fighters. Technological superiority. The NGAD program emphasizes several cutting-edge technologies, including stealth. The NGAD is designed to be significantly stealthier than the F-22, utilizing advanced materials and coatings as well as a tailless design to minimize radar detection. Advanced sensor technology. The integration of artificial intelligence (AI) enhances situational awareness, allowing for improved decision-making and operational effectiveness in combat scenarios. Adaptive engines. These engines are designed for improved range and fuel efficiency, enabling the NGAD to perform in the vast Indo-Pacific theater effectively. In contrast, while Chinese fighters like the J-20 and J-35 incorporate stealth and advanced avionics, analysts argue that U.S. technology currently holds an edge in several critical areas. Cost concerns. The estimated cost of the NGAD program poses a significant challenge, with projections around $300 million per unit. This financial aspect has led to potential program delays and raises questions about budget allocations within the U.S. military. Conversely, there have been fewer publicized cost challenges regarding China's fighter development, allowing for a more streamlined approach in their advancements. Manned versus unmanned aircraft. A notable divergence in strategy exists between the U.S. and China regarding the future of air combat. The U.S. is exploring the integration of unmanned systems alongside manned fighters, reflecting a shift towards a more hybrid operational model. In contrast, China continues to invest heavily in manned aircraft technology, indicating a commitment to traditional air combat roles. This distinction highlights broader debates within military circles regarding the future landscape of aerial warfare. Conclusions from analysis. Current status in the race. While China is narrowing the technological gap, experts caution against prematurely declaring a shift in the balance of power in air combat technology. The U.S. retains a qualitative advantage in critical areas including stealth capabilities, AI integration, and operational readiness with the NGAD program. The advancements made by China are significant but do not yet surpass the established capabilities of the U.S. Future implications. As both nations continue to develop their respective fighter programs, the competition will undoubtedly shape future air combat strategies and military capabilities. The U.S.'s commitment to the F-35 program and the NGAD underscores its determination to maintain air superiority, while China's advancements reflect its aspirations in military aviation. Summary. In summary, the U.S. remains at the forefront of sixth-generation fighter development driven by the NGAD program's significant advancements. While China shows notable progress, it has yet to outpace American capabilities. The evolution of military aircraft technology is a critical area for national security and geopolitical maneuvering, and the ongoing competition between these two powers will likely influence the future of air combat for years to come. The detailed comparison between the U.S. Air Force's next-generation air dominance NGAD program and China's sixth-generation fighter initiatives reveals several counterintuitive insights that challenge common perceptions about military aviation advancements. 1. Perception of technological superiority. A common belief is that China is rapidly catching up or even surpassing the U.S. in military aviation technology. However, the NGAD program's advancements, including a prototype that flew as early as 2020, suggest that the U.S. has a considerable lead in the development of sixth-generation capabilities. This counters the narrative that Chinese advancements are primarily driving the technological race, as it highlights the U.S. achievements that may not be as publicly recognized. 2. Cost implications. The NGAD's estimated cost of $300 million per unit raises concerns about the sustainability and feasibility of the program, which contrasts with the perception that technological advancements come without significant financial implications. While China appears to be progressing with fewer publicized cost challenges, this might not reflect the full picture of their military budget allocations and potential financial strains. The idea that cost is a secondary concern in military tech development is thus misleading. 3. Manned versus unmanned aircraft debate. There is a prevailing assumption that unmanned systems will completely replace manned aircraft in the future of air combat. However, the U.S. emphasis on unmanned capabilities alongside its commitment to manned fighters contradicts this assumption. Similarly, China's sustained investment in manned aircraft technology indicates a strategic choice that diverges from the narrative of a fully unmanned future, suggesting that both nations see value in maintaining a hybrid approach. For operational readiness versus development timelines, the expectation that China's recent unveilings of fighters such as the Chengdu J-20 and Shenyang J-35 indicate an imminent shift in air dominance overlooks the fact that the U.S. has already achieved significant milestones with the NGAD. While China's technology is advancing, the operational readiness and integration of these systems remain unproven compared to the established capabilities of U.S. aircraft, including the F-22 and F-35. 5. The narrative of U.S. decline. The discussions surrounding military technology often lean towards a narrative of U.S. decline in the face of rising global competitors. However, the NGAD program exemplifies a robust response to these challenges, with leaders like former U.S. Air Force Chief Will Roper asserting that the U.S. is ahead in several critical areas. This counterintuitive perspective challenges the notion that the U.S. is losing ground, emphasizing that the competition is more nuanced than a simple race to superiority. 6. China's data theft and technological acquisition. The idea that China is independently developing advanced technologies without external help is contradicted by evidence of significant efforts to acquire technology through cyber means. This reality complicates the narrative that China's advancements are solely due to indigenous innovation, as it raises questions about the authenticity of their technological capabilities. 7. Public and media perception. The media often amplifies stories of Chinese advancements in military technology, which can skew public perception towards an exaggerated view of their capabilities. The reality of ongoing U.S. innovations and the historical context of military development timelines suggests a more balanced view is necessary, as the public discourse may not accurately reflect the current state of military aviation technology. In summary, the comparative analysis of the NGAD and China's sixth-generation fighters reveals several counterintuitive insights that challenge dominant narratives surrounding military aviation. The U.S. maintains significant advancements in operational readiness, while the complexities of cost, technological acquisition, and strategic choices complicate the perception of a straightforward race for dominance. The comparison between the U.S. Air Force's Next-Generation Air Dominance NGAD program and China's sixth-generation fighter advancements reveals critical aspects that many may overlook, but which are significant for understanding the future of air combat technology and military strategy. 1. Historical context of development timelines. One important detail often overlooked is the historical context of the NGAD program's development timeline compared to China's sixth-generation fighters. The NGAD program began in the early 2010s with a prototype flight achieved in 2020. In contrast, while China has recently showcased its own sixth-generation fighters such as the Chengdu J-20 and Shenyang J-35, these developments are more recent and do not represent a fully operational capability as seen in the NGAD. This head start is crucial. It indicates that the U.S. has been able to refine its technology and integrate lessons learned over a longer period. The implication here is that the U.S. may maintain a qualitative advantage in operational readiness and technological sophistication as it further develops the NGAD, whereas China's rapid advancements may still be in the nascent stages. 2. Technological superiority and AI integration. The emphasis on technological superiority, particularly in AI integration and sensor technology, is another critical area that deserves more attention. The NGAD's focus on advanced sensor systems powered by artificial intelligence is expected to provide unmatched situational awareness, enabling pilots to make superior tactical decisions. This capability is not just about enhancing existing systems, it fundamentally shifts the paradigm of air combat by enabling manned aircraft to operate in synergy with unmanned systems. The significance of this is profound. As warfare increasingly relies on information dominance, the ability to process and react to data in real time can dictate the outcomes of engagements. In contrast, China's advancements, while impressive, may not yet match this level of integration and sophistication, which could hinder their effectiveness in future conflicts. 3. Cost and economic viability. The economic aspect of the NGAD program, particularly its projected cost of $300 million per unit, is often framed as a challenge. However, this cost also signifies a commitment to high-end capabilities that could deter adversaries. The financial implications of developing and maintaining a fleet of these advanced aircraft could strain budgets and lead to tough decisions regarding prioritization of military spending. In contrast, the lack of detailed financial disclosures about China's fighter development raises questions about the sustainability of their advancements. If China's military aviation program relies heavily on state funding without the same level of scrutiny faced by U.S. programs, there could be significant risks of inefficiencies or technical stagnation in the long run. 4. Manned versus unmanned aircraft debate. The ongoing discourse regarding the future of manned versus unmanned aircraft is another nuanced point that merits special attention. The U.S. is exploring a paradigm shift towards unmanned systems while China continues to invest heavily in manned fighters. This divergence suggests differing strategic philosophies that could have long-term implications. If the U.S. successfully integrates unmanned systems alongside advanced manned fighters, it could dominate future air battles through a combination of speed, range, and operational flexibility. Conversely, China's focus on manned aircraft could reflect a reliance on traditional combat methods, potentially limiting their adaptability in a rapidly evolving battlefield landscape. 5. Strategic implications of ongoing development. The strategic implications of both nations' ongoing developments in air combat technology are paramount. While China is making notable progress, the qualitative edge that the U.S. retains in several areas, particularly in stealth AI and operational readiness, suggests that it is still in a strong position to influence the future of military aviation. The narrative that China is winning the fighter race often overlooks the broader context of military doctrine, operational readiness, and technological development cycles. As these two superpowers continue to enhance their respective capabilities, the competition will shape not only air combat strategies but also geopolitical power dynamics globally. Conclusion. In summary, the comparison between the U.S. NGAD program and China's sixth-generation fighter developments reveals significant insights that are often underappreciated. The historical context of development timelines, technological superiority in AI and sensor integration, economic viability and cost considerations, the debate over manned versus unmanned aircraft, and the strategic implications of ongoing advancements all contribute to a complex picture of the future of air combat. Understanding these elements is crucial for grasping the potential trajectories of military aviation and the geopolitical landscape in the coming years. 1. Technological superiority and strategic implications. The NGAD program emphasizes cutting-edge technologies such as advanced stealth AI integration and adaptive engines, which could provide the U.S. Air Force with a significant qualitative edge over China's developing fighter capabilities. The implications of this technological superiority extend beyond individual aircraft performance and into broader military strategy, shaping air combat dynamics and national security considerations in the Indo-Pacific region. 2. Cost and program viability. The projected $300 million unit cost of the NGAD poses substantial challenges for its development and deployment, raising questions about budget allocation and the sustainability of the program. In contrast, China's development of sixth-generation fighters appears to be less burdened by similar financial constraints. This cost disparity could influence the pace and scale of each nation's military modernization efforts, affecting their long-term strategic positioning. 3. Manned versus unmanned aircraft paradigm. The divergence in U.S. and Chinese approaches to manned and unmanned aircraft highlights a critical debate within military aviation. The U.S. is contemplating a transition towards unmanned systems while China continues to invest heavily in manned fighter technology. This difference reflects broader strategic philosophies regarding the future of air combat and could have profound effects on operational tactics, pilot training, and force structure in both nations. For current status and future outlook, while China is narrowing the technological gap with impressive advancements in fighter technology, experts caution against prematurely declaring a shift in air combat power dynamics. The U.S. maintains a qualitative advantage in several critical areas that are essential for dominance in future aerial conflicts. The ongoing evolution of military aircraft technology, driven by both nations' ambitions, will significantly shape the future of air warfare and global military balance. 1. The Cold War arms race. During the Cold War, the United States and the Soviet Union engaged in a fierce arms race characterized by the development of advanced military technologies, including nuclear arsenals and fighter aircraft. The competition led to significant innovations in air combat capabilities, with the U.S. developing the F-15 and F-16 fighters while the Soviet Union produced the MiG-29 and Su-27. This rivalry defined military strategy and technological advancements for decades and set the stage for modern air combat dynamics. 2. The Battle of Britain 1940. The Battle of Britain marked a significant turning point in World War II and showcased the importance of air superiority. The Royal Air Force RAF defended the United Kingdom against the German Luftwaffe's extensive aerial attacks. The technological innovations in radar and aircraft design, including the Spitfire and Hurricane fighters, played a crucial role in the RAF's success. This historical case underscores the critical nature of air power in warfare and the ongoing evolution of fighter technology. 3. The Vietnam War 1955 to 1975. The Vietnam War highlighted the complexities of air combat and the role of technological advancements in military strategy. The introduction of jet fighters such as the F-4 Phantom II and MiG-21 illustrated the competitive nature of aerial warfare. The conflict saw the U.S. military grappling with the effectiveness of advanced technology against guerrilla tactics and asymmetric warfare. This historical example reflects the ongoing challenges nations face in maintaining air superiority amidst rapidly evolving combat environments. Future outlook: NGAD versus China's 6th-gen fighter program. As the geopolitical landscape shifts and technological advancements accelerate, the competition between the United States Air Force's Next-Generation Air Dominance (NGAD) program and China's 6th-generation fighter capabilities will continue to evolve. Here are key predictions and considerations for the future of this rivalry. 1. Technological advancements and integration. By the 2030s, both the NGAD and China's 6th-generation fighters will likely integrate cutting-edge technologies including advanced artificial intelligence, enhanced stealth capabilities, and superior sensor fusion. The NGAD is expected to achieve a level of operational autonomy through AI, enabling it to operate alongside unmanned systems effectively. This could redefine air combat strategies, allowing air forces to execute complex missions with greater efficiency and reduced risk to human pilots. China will likely continue to invest heavily in its fighter programs, seeking to narrow the technological gap. However, the U.S. is expected to maintain its edge in areas such as sensor technology, data link capabilities, and electronic warfare, emphasizing a network-centric approach to combat. As both countries embrace AI, the development of autonomous unmanned combat aerial vehicles (UCAVs) will also change the dynamics of aerial engagements. 2. Cost and economic factors. The projected cost of the NGAD, estimated at $300 million per unit, presents significant budgetary challenges for the U.S. Air Force. This financial burden may lead to delays in the program's full-scale production and operational deployment. The U.S. will need to balance funding for NGAD with existing programs like the F-35, which could result in a tempered rollout of next-generation capabilities. In contrast, China's approach to funding and developing its fighter programs appears less constrained, indicating that it may achieve faster operational readiness. By leveraging state resources and a robust defense industry, China could field its advanced fighters before the NGAD reaches full operational capability. 3. Strategic military doctrine. As both nations evolve their military doctrines, the implications of air superiority will take on new dimensions. The U.S. is likely to continue emphasizing multi-domain operations, integrating air, land, sea, cyber, and space capabilities. The NGAD, with its advanced sensor arrays and AI, will be crucial in supporting these strategies. China's military doctrine is predicted to focus on asserting its regional influence, particularly in the Indo-Pacific. The development of its 6th-generation fighters will play a vital role in this strategy, potentially challenging U.S. air superiority in contested environments. As China seeks to expand its reach, the dynamics of air combat may shift, requiring the U.S. to adapt its strategies accordingly. 4. International collaborations and alliances. The competition between the NGAD and China's fighter programs will also influence international defense collaborations. The U.S. is likely to enhance partnerships with allies and partners such as NATO members and Indo-Pacific allies like Japan and Australia to create a unified front against potential adversaries. The sharing of technology, intelligence, and joint training exercises will be pivotal in maintaining air superiority. China, on the other hand, may seek to bolster its alliances with countries that are developing their military aviation capabilities, potentially leading to a new axis of military cooperation. This could include technology transfers and joint development projects with countries like Russia and Pakistan, further complicating the global military landscape. 5. Geopolitical implications of air superiority. The outcome of the NGAD versus China's 6th-generation fighter development will have significant geopolitical ramifications. If the U.S. maintains its technological edge, it could deter aggressive actions by adversaries and solidify its position as a global military leader. Conversely, if China successfully fields advanced fighters that can match or exceed U.S. capabilities, it may embolden its military assertiveness in regional disputes, particularly in areas like the South China Sea and Taiwan Strait. 6. Public perception and policy impact. Domestic and international public perception of military capabilities will play a crucial role in shaping policy decisions. As both nations showcase their advancements, public support for military spending and defense initiatives will be influenced by perceived threats and the effectiveness of each country's programs. This could lead to shifts in funding priorities and defense strategies, depending on which nation is viewed as maintaining or losing its technological edge. Conclusion. In summary, the competition between the NGAD and China's sixth-generation fighters is poised to shape the future of military aviation and air combat strategies. While the U.S. currently holds a qualitative advantage, ongoing developments in technology, cost considerations, strategic military doctrines, and international alliances will play critical roles in determining the outcome of this rivalry. The next decade will be pivotal as both nations advance their capabilities with implications that extend far beyond the realm of air combat, influencing global security dynamics and geopolitical relationships.